descriptive geometry. 3FB, skewed lines. So again, this is the last of skewed lines we're going to practice drawing. And again, the example given here is like you're working for an electrical power company, and you have to make sure that the lines don't get too close to each other. They have to be separated by a minimum distance, which is our shortest distance, to keep you from electrocuting yourself. So we've got multiple lines running different areas. They're meeting and connecting in different places. So we need to find out. To do that, we need to first find the true angle of this, or horizontal view. So we need to find out what the actual true angle is. So we're going to do that first. So let's do a few things real quick. Line it up to a straight edge, straight line, and tape it down once you got it lined up. Dang it. Sorry. There we go. And let's just do I'm just going to draw 6 to the fold line, 8 to here, 5 to the fold line, connect 7. Now, why did I not bring the 5 up? You can. If you want to. But here in a minute, since we are giving this as like the true length, think of this, this is like the true length of 5, 6. So I'm going to use that as my reference coming up here. And then I'm finding coming here this distance for the 7, and then I'm going to connect to that perpendicularly and pull that one up for the 7, 8, because 7, 8 is not the true. Does that make sense? So we use this distance here as the true length. We do not use the distance here. We're going to do the perpendicular lines here in a minute. So it's just one of those things. Just trust me on this. It's one of those rules, one of those Manger rules. I always say it right. Redneck says it wrong anyways. He's smarter than me. All right, so our first distance we're going to need to know is we're going to need to know the little a here. We need to know the b here. I'm going to need to know a little distance c, and then the distance d. So I'm going to need to know from there to there, from there to there, there to there, there to there, here in a second. All right. Again, to find true length, true angle, we're going to draw a line parallel to our edge view through point 1. So this is our true length line, so that, again, that would be our true length, our edge view. Tape it. Let's move it up a little bit. Line it up. There we go. Third one. Now here's the weird, 5 and 7 actually line up, right? They go together. Go all the way up to point 6 here. Pull it out. Point 8, we come from back here. This isn't true length, so we're measuring straight to that true length. This is not our true length, we're trying to find it, so we're pulling it out here so we can find the true angle. That's why we do those. Let's transfer our measurements. Our farthest one would be distance D. D. B. Sorry, dyslexia was kicking in for me there for a moment. C. And then A. right, split again, connect the dots. All right, let's go ahead and find, let's just find 7, 8. So 7 we know falls on here, and I know 7 goes to distance A, so it's going to go there. Let's find 8. Here is 8. 8 goes to a distance of D, which is the farthest one out. There's 8. So we're going to find the true angle for this so that we can find the shortest distance for this. 7, 8. All right, let's find 5, 6. 5 comes down to B. Here's 5. There's B. 5. 6, 6, C, 6. So I now have the triangle. I've found the triangle. Now that I have the true angle, I can find the shortest distance. So how do I do that one? So I want it again going through here. Move this up. I don't need to really move the paper right now. All right, so I want it going perpendicular, so I'm going to use 5, 6 is my perpendicular line because that's going to be the base for it to find that shortest distance. So I'm going to line the bottom edge of my triangle here with that, and then I'm going to move it over until it hits that point 2. And if you want to make sure you got it right, you put those together, they form that perfect 90-degree angle, right? So I'm now going to use that as my guide for the straight edge. See how that lined up to that? That lines up to the 5, 6. So, sorry. Oof. So I now have that fold line that's running through here. So next I need to build and find that triangle. So to do that, the shortest distance, sorry, not triangle, we need to find some other distances. So we need to know the distance here, which is our E. We need to know the distance here to here. Sorry. Why is my line? Am I not working? Oh, no, I don't want that. Sorry. From our fold line down, E. Then we need to know F, and we need to know little g. So distance G is obviously our farthest one out. G. I marked it over here. G. Distance F. Distance F. Distance E. Okay, so we want to find the shortest distance for the 5, 6. So now we're going to find 8, 7, so we can get the true length of the 8, 7. because we had true length of 5, 6 here, but we don't have the true length of 8, 7, so we're going to find the true length of 8, 7 now. All right, so we're going to follow back. 7 comes back to F, and it's along this line. So I'm going to find 7 and F right here. That becomes 7. 8. 8. 8, if I look on here, is my farthest distance out. 8. And my triangle moved a little bit on me. There we go. That's better. So there's our 8. Now, how do we find that shortest distance, that big A and big B? On 5, 6. Sorry, excuse me. So we line it up again so that we can get that 90-degree angle to where it hits for that 5, 6. The 5, 6 comes here. There we go, to here. So I formed that 90-degree angle. And this is now the shortest distance. From here to there is now your shortest distance. So you would need to measure it. And then you're going to measure it using your regular engineering scale. And then remember, each inch is equal to a foot at 5 feet. So you get 5 feet in an inch. And so you'll have to do the math and tell me what the distance is. And then once you're done with that, fill in your title block at the bottom, go over everything. Remember, outline Sam Houston, skewed lines, etc. Fill it all out and turn it in for grading. Oops, I almost completely forgot about we need to transfer that shortest distance over to all other views too. So, just to make this a little easier for me, you don't have to label it, but I find it's easier if I use it for my point of reference. So AB is the shortest distance, right? Big A, big B is the shortest distance. So now we need to find that shortest distance, that line, and we need to draw it here in the triangle, here in this edge view, and here in the frontal view. So get my pencil, and let's do a couple things. All right, so the thing is, we already know that B goes along this line, right? And then we know that A is going to come along here. What we're not 100% sure on is where's this line going to hit. So, step 1, line your straight edge up again with that line that's at reference. Bring it down, bring A over. So I bring A over. Get my triangle. Did I draw that right? I want to make sure. I got off a little bit. Okay, come on. Yeah. Okay. There we go. So it got off just a little bit. And then you connect using that 90-degree from there. That just does not look right. Sometimes you have to trust your gut instincts and try to look at something and figure out what's off, what's wrong here. Okay, that's a true 90. B is going to fall along that line. Just checking some things. Okay, yeah. Well, it doesn't look 100% right, but that's where it's lining up to. And the reason that is because that angle here is 90. So that angle's got to be 90 also. If you're not sure, put those triangles on there and check. And you can notice that you got your perfect 90. Okay, next now we want to transfer this AB down. Okay, B is here, A is here. Line that up with that horizontal. There we go. And again, remember, get that engineering skill. Lay that on here. Find that shortest distance. What is that shortest distance? And then times that times 5 feet. Okay? You can do the math. Don't forget to fill out the title block.